if you have any issue in the lab, any issue in the concept, like whatever you have done the last week, okay, so you can ask, no issues, I will repeat that concept fresh, will do that lab activity, there is no issues. Okay, now
Okay.
before going to start this course, let's take a small introduction, okay, so that we will get to know each other, and then we will start our courseware. Fine. So
Yes.
let's start with you guys one by one. Like, let's start with Nicholas. Hey, Nicholas, are you there? Okay. Huawei. Great. Okay. Good. Now, Lord Ben.
Thank you very much. Yes, mine has been a little bit wide scope, Cisco, Arista, a little bit of Huawei Extreme Networks, and a few other products. Have people, CCNT, data center, enterprise, security. Have some working knowledge and experience with all Nexus platforms.
Okay.
And with over 10 plus years into the field of networking, really.
Okay. Great.
Thank you.
Samuel.
Thank you, Rakesh. My name is Samuel Okello. I've been into the field of networks and collaboration
Oh, great.
for long, and I've also been venturing into security, and now in data center. I'm CCNP enterprise collaboration. I did data center, though I had not gone through proper classroom training. So I needed to have this training to enhance my ability into handling data center solutions. But that is my area of scope of work.
Okay.
Thank you.
So, guys, my name is Rakesh Kumar. I have more than 15 years of experience in IT training. My core domain is data center. In certification, I am CCIE data center certified. I have passed my CCIE lab in 2019, and my CCIE number is 63812. Apart from CCIE, I'm CCSI certified, which is Cisco certified. This command show endpoint, some of the IP address, say 20.0.0.1 Ethernet 1/12. Let's say 20.0.0.2 tunnel 8. you have get this kind of output, right? Some of the endpoint will receive by the specific interface, and some endpoint information is coming by the tunnel, right? So who created this tunnel? Automatically.
Epic.
In this ACI fabric here, the VXLAN work automatically. Getting my point? Any confusion?
That's okay.
Take a
good.
screenshot of.
Yeah, let me take a screenshot. I have a screenshot.
Okay, great. Default protocol used in ACI. Okay. ISIs. Yes, guys. What is the use of ISIS protocol? Intermediate system to intermediate system.
It's a routing protocol, and in this case, it is used as is it underlay. Which one is on top? The one that enables VXLAN communication.
Okay.
It's an underlay routing protocol. Is it underlay or overlay? I always confused them.
Okay, no issues. ISIS is basically a routing protocol in, you can say, in the enterprise network or in the service provider network. But into the data center technology, this ISIS protocol used for spine and leaf adjacency. Okay, it is only infrastructure management protocol. It is not doing any kind of routing. It is not doing any kind of switches. Once your final leaf are registered on the controller, it will build a adjacency database with the help of the tap IP address. Okay. Point number 2, VXLAN. By default enabled. In ACI, IVXLAN tunnel formed with the help of tap IP of spine and leaf. Getting my point? Third protocol, DHCP. By default, enabled on Epic. Epic provide step IP to registered spine and leaf. Take the screenshot, guys. Done?
Yes.
Okay.
It's done.
Can I clear it?
Yes.
Next protocol is COOP. Council of Oracle protocol. Yes, guys, what is the use of COOP? Anyone?
COOP is used to share the local station table from the leaf with the spine.
Leaf with spine, correct. So COOP work here. Okay. So under this LST, we have that information, let's say 1/2, 1/2. So on the 1/2, there is a IP address, let's say 10.0.0.1, having the MAC address this. So this information is exchanged by the COOP protocol here. So it is having the database, let's say 10.0.0.1, having the MAC address AAA present on 1/2 on the leaf 101. This is known as what? PST, proxy station table or COOP database. Getting my point?
Yes.
Forward, leaf, LST database to spine. But it is not forwarding spine to leaf. Getting my point? It is always leaf to spine. But there is one mechanism which we discussed today that is known as basically the bounce entry. In that particular mechanism, it is forwarding that information to the leaf also, but only the bounce entry information. Point number 5. OP flex. Yes, guys, what is the use of OP flex? It converts GUI configuration to CLI configuration. Okay, so this OP flex work here. Between the controller and into the leaf. So you are doing all the configuration on the GUI, and then when you are pushing that configuration to the leaf device, the configuration will reach here, and then it will convert the relevant GUI configuration to the relevant CLI configurations. Getting my point?
Yes.
Point number
Yeah.
6, LLDP used to discover fabric. Point number 7, MPBGP used to exchange routes between leaf in L3 out. Take the screenshot. If any point you want to ask, guys, you can ask, no issues.
Can you throw more light on the GST?
GST, okay, no issues. Screenshot is done.
Yes.
Don't worry, GST thing we have to discuss today in detail because our today's topic is endpoint learning only. But again,
Okay.
no issues. Let me just give a brief information for the time being. So let's suppose here my MAC address is AAA or IP address is 10.0.1. MAC address is BBB 10.0.0.2. All these devices will learn the LST database, LST information via the R protocol. Okay. So they will get that information, let's say 1/2, 1/2. Interface can be any interface, no issues. So they will get that information 1/2 is connected with AAA having the 10.0.0.1. Here 1/2 connected with BBB 10.0.2. One slash 3 10.0.0.4. Here there is a coop working. What coop will do? We take this information, give to this. So that spine is having that information now. 10.0.0.1 AAA 1/2 101. 10.0.0.2 BBB 1/2 102. 10.0.3 CCC 1/3 103. 10.0.4 DDD 1/3 104. This database is known as what? TST, proxy station table, or COOP database. Okay. Now, let's suppose you are on this endpoint and you are going to ping.
Excuse me?
10.0.2.
Hello?
Yeah.
Yeah, PST said it stands for what?
Proxy station table.
Okay. Thank you.
Now, let's suppose on this endpoint you run this command. So what will happen now? This traffic goes to leaf. Okay. Leaf firstly check their LST. Okay. Local station information. Do I have that information or not? If not, then this request will go to the BD, bridge domain. In the BD, there are two options, hardware proxy and flood. I will discuss these sections in detail today. Okay. Just for the brief information, whatever you have done in your last course, DCACI, that I am talking right now. Under the BD, by default, hardware proxy is enabled. Hardware proxy meaning is that if you don't have that information in your local station table, then forward that to the spine. Spine have all the information about all the endpoints, right? It will check that thing 10.0.2 present on this leaf. So traffic will be forwarded here. It reach here, it check the LST, it will tell that thing, okay, this IP address, this MAC present on 1/2, traffic reach here. After that, it will give the reply. So when the reply will come, it goes the same way. Once this communication established, then automatically there will be a tunnel between the two leaves. Then once this communication is established, this IVX LAN tunnel will formed, and automatically on that leaf you will get this information 10.0.0.2 reach by any tunnel number. This information is basically known as GST information, global station table, GST. Okay. Once there is a communication between the two endpoint, okay, then the GST table will be created. But if you tell like I want to see LST and GST separately, you can't see that thing. Okay. Why? Because there is a single command for that, and that command is show endpoint. Getting my point?
Yes.
So let's say here it is tunnel 8. If you do any communication between, let's say from here to here, so there will be another tunnel. If you communicate here to here, there will be another tunnel. If you communicate here to here, there will be another tunnel. Getting my point?
It's clear.
So today we have to discuss only these kind of stuff. Take the screenshot.
It's done.
Great. Can I clear it completely?
Yes.
Okay. Okay. So this you have already done, I think so. That will be your discovery number. I think so. The third lab, which you have done in the last course. Okay. I'm going to repeat that thing so that you will get all those concepts once again, the physical and logical flow. And then I will relate the same topology with our DCACI course. Okay. Okay. So I will do that thing. Before jumping to this, just have you received the Cisco email, guys? Any Cisco email regarding the D kit? Can you just confirm me once?
Yes.
Okay, great. All of you are having the Cisco certifications, right?
Yes.
Now, that certification belongs to your personal email or official email.
The email from Cisco, I don't know whether it is right.
No. That if this email comes to your official one, no issues. But your Cisco certifications, whatever certification you have done on the personal email ID or on the official email ID.
Oh, I've done, I need to check again. But I know I use my corporate email to access my partner portal. But during registrations, I use my personal email, exam registration.
Guys, why I'm asking now, most of the students are doing this mistake actually. See, this course, this DKT is a courseware, book. Okay. Against this DCACIA course, okay, you will get, I think so, 32 CE points. Okay. These CE point you can use to renew your certification also. Getting a point?
Okay.
So mostly this issue came, and that is a very complex issue right now. All your certification, you have to firstly check. Don't redeem this courseware until and unless you don't have that clarity. Certification is on your personal email ID. And if you register courseware on official ID, then you can't use these points. Why? At that time, you are creating two separate accounts. Clear my point?
Yeah.
Yes.
These are used to renew our certifications. And if you registered here, then it can create the issue. Getting my point?
Yeah.
That's
So
clear.
firstly, you have to check that thing, your certification belongs to which email. And how you can check that one?
From the Cisco website, personal information.
Correct, correct. From the personal information, or you can do that thing like, okay, you go into the Google and you can search that thing, na, Cisco Pearson View exam. When you log in there, na, when you are registering your exam, getting my point? There also you
Yes.
can get that information. Clear my point?
Okay.
Okay. So we have to do this thing today. Okay. In the lunch time, you just make sure that thing, your official, your certification map to official or the personal email ID. After that, we will do this task. Okay.
Okay.
Okay, cool.
Second thing, labs. In this course, all the labs will be Cisco lab. Every day we are getting 10 hours lab access from morning to 10 hours, whatever 10 hours we have. Okay.
Okay.
You can utilize our Cisco lab also. Okay. Which you have already credential, I think so, which you used in the last week. Getting my point? But on those labs, maybe certain labs will be not work. Reason is that, like, okay, the devices are the first generation devices and we have only single port. Getting my point? We have only
Right.
one port there. Okay. So let's firstly register our Cisco lab so that there will be no confusion at that time. Just give me a second. Let me just register myself first. So firstly, you have to log in here. I'm putting all the detail into the chat box. Okay. Then it will ask the username and password. Then Login will use these credentials. Samuel will use these credentials. And Nicholas will use these credentials. It will ask one more thing. What is the instructor token? So that will be your instructor token. Instructor token will be common for everyone. Getting my point?
Yeah.
Anyone, you can share the screen and just log in once so that others will get how to register. Samuel, can you share your screen?
Okay.
So, which email do we use? Hello?
Yeah.
Which email address do we use? And let's just look at some and how it does it.
Lordwin, your voice is not coming clear.
I was asking that which email do we use?
Share your screen. Share your screen. Firstly, you had to click on that URL. It will ask the username and password. Put your username and password, which I have shared on the screen. It will ask.
So I'm here. I've done the first page, so I'm here.
You are here. Just
address do I use?
here the username is like I shared on the chat box. This for you it is 20 23 08 24 40 39 16.
Yes, I've already logged on to the first page. This is my username.
Once you
So
log in, then again it will ask the name. Okay. You can put the name.
Now here I put my actual name.
You can put your name, no issues. It will ask the CCO ID. You can skip that one.
And
on the last
email
option, it will. You can put the email address, no issues.
Any. Email. Okay. Is this okay?
Instructor token, I have put the HADRY. Instructor token.
Yeah, I've already put it in.
Yeah, just put that instructor token and submit.
Huh?
I think I'm there.
Share your screen, Samuel. Correct. Once you put the correct instructor token, you will reach here. Okay.
Yeah.
So these are the discovery which we have to do. Today we will do discovery 1, 2, and 3. Okay.
Okay.
Nicholas, are you done? Lordwin?
All good?
Okay, cool. So let's focus on courseware now. I'm sharing my screen once again. So this is the book which you will receive. Okay. So our day 1 in this DCACI A. We have to discuss ACI advanced packet forwarding, examine local and remote endpoint. Okay. So ACI construct. In the ACI, we have two constructs. One is physical construct and one is logical construct. In the physical construct, we have VLAN pool, domain, AAEP, interface policies, interface policy group, interface profile, and switch profile. Logical construct, tenant, VRF, PD, application profile, and EPG. Okay. So we have to discuss all these things. Getting my point?
Yes.
Cool. Take the screenshot of this. Then
Yes.
okay. Now the first point is VLAN. Create a VLAN pool for endpoint. Okay. We have to create a VLAN pool for the endpoints. Now, in this, define allocation mode. So there will be two type of allocation mode. One is static and one is dynamic. Yes, guys, when we have to use static, anyone? When we have to use static allocation mode and dynamic allocation mode?
I think static is used when we are in the same EPG, or if the endpoints are going to be in the same group.
Okay.
Yeah. In dynamic is when you have different subnets, different endpoint groups.
No, guys. Static, if endpoint physically connected with the leaf, like this way. So I will use here a static. Dynamic is what? When VM, when you can say endpoint is VM. Getting my point?
Yes.
So here you will use static, and let's say you have done that VMM integration lab, right? At that time you are creating the dynamic VLAN pool. Static VLAN pool, if you create, it will not work.
Oh, okay.
Okay. Take the screenshot, guys. Put the screenshot in one document. Okay, this will be your notes forever. If you go with this particular sequence, soon you will be the expert. Okay. Only these, you can say, if we get the relationship in all these configurations now, then the ACI is easy. Otherwise, like, we will find out the fault every time. All good? Can I clear
Yes.
this?
Yeah, it's done.
Okay. Next point. Domain. Domain. Domain is what? Domain basically define that thing like, okay, what kind of device is connected with the leaf? For example, currently I'm connected with a PC. Okay, so I will go with the physical domain. If I'm connecting with a ESXi server, then I will go with the VMM domain. If I'm connecting with a router where I'm doing the routing, external routed domain. If I'm connecting with a switch, then external bridge domain. Getting my point? So under this, there will be 5 options actually. Physical domain, external bridge domain, external routed domain, FC domain, and VMM domain. If leaf connected physical endpoint load balancer, firewall. External bridge domain, Ethernet switch. Leaf connected with the router. Leaf connected with FC network, fiber channel network. Leaf connected with ESXi, Hyper-V, or any other virtual environment. Getting my point?
Yes.
Now, here one important point. Create a domain and associate VLAN pool. Any confusion, guys?
Sounds clear here.
Take the screenshot. Done?
Yes.
Okay. Point number 3. Point number 3. AAEP attachable access entity profile. It is a logical container which associate domains. So VLAN pool associated into the domain, domain associated into the AEP. Getting my point?
Okay.
So I can say that thing, my AAEP is having the information about my VLAN pool, right or wrong? AAEP is having the information of VLAN pool, correct? Because domain under the AEP, I associated the domain and VLAN pool associated into the domain. So I can say that thing. Getting my point?
Yeah.
Yeah.
Take the screenshot. Can I clear, guys?
Yeah.
Point number 4, interface policy. Why we are creating the policy? The reason is that whatever Nexus 9K devices we are using as a leaf, by default they don't have any configuration. Okay. So now create interface policies for endpoint. For example, let's say CDP, link level policy, LLDP policy. Okay. Now, point number 5. Interface policy group. We cannot apply policy directly to the interface. Okay. Policy should be called into the policy group. Create a interface policy group and associate all policies and AAEP to policy group. So all these policies are associated here. This AAEP is also associated here. So I can say that thing, this interface policy group is having information by VLAN pool, right or wrong?
That's right.
Take the screenshot.
Okay.
Can I clear now?
Yes.
So we created the policy group, but we haven't defined that thing, that policy group apply where. So for that we have what? Interface profile. Okay. So under the interface profile, define the interface on leaf which connected with endpoint and associate interface policy group. So now this policy group, I have associate, let's say 1/12, and I associate that thing here. Okay. So whatever policies I have called into in this policy group, that will be applied to this 1/12 interface. Getting my point?
Yeah.
Then point number 7, switch profile. Define leaf switches which connected with endpoints and associate interface profile. This interface profile associate here. So we define that thing, okay, leaf 101 and whatever interface profile we have created, let's say 1/12, I will apply that. This is what my physical construct. Getting my point?
Yeah.
Take the screenshot. Done, guys? Now let's discuss the logical construct now. So point number 1 is tenant. So tenant is what? Tenant is a customer, a particular department, or a business unit. Okay. There are 3 default tenants. One is common, one is infra, and another one is management. So management tenant is basically used for inbound and outbound management. Okay. Infra tenant is for internal communication between spine leaf and the controller. Common tenant is basically used for the common services. For example, like you have the multiple tenants, and between the multiple tenant, you have to use the use some common services. Okay, for example, like internet access, DHCP. So in that case, you can use the common tenant. Okay, so we will use the common tenant maybe on day 3. Okay, when we are doing the route clicking part. Okay, so you can create multiple tenants, no issues. You can create multiple tenants. Point number 2, VRF, virtual router forwarding. VRF is what? Layer 3 boundary in ACI. You can create multiple VRF within tenant. Clear? Yes, guys. Any confusion?
Clear.
That's clear.
Take the screenshot. Can I clear this one?
Just for me.
Point number 3, bridge domain. Okay. Bridge domain is what? Let's say layer to boundary in ACI. Bridge domain must be associated with VRF, we have to create subnet inside BD. We have to create subnet inside BD. BD subnet will be default gateway for endpoints. Okay. One BD will be associated with one VRF. One VRF can be associated with multiple BD. Getting my point, guys?
Correct.
Yes. Yes.
Take the screenshots. Then
Yes.
point number 4. Application profile. It is container for EPG. You cannot create EPG directly. You have to create first application profile. Inside the application profile, you are creating the EPGs. Point number 5, EPG endpoint group. EPG is container for endpoint. EPG must be associated, one EPG must be associated with one BD. with multiple EPGs. Endpoint belongs to same EPG, can communicate by default whether they belongs to same subnet or a different IP subnet. Different EPG communication require contract. Any confusion, guys?
Looks good.
Take the screenshot. Done?
Yeah.
So this is the base, whatever we have discussed till now. Okay. If you are good in this, then rest of the things will be very easy. So what we have discussed till now, we discuss ACI physical construct, in which I have discussed VLAN pool, domain, AAEP, interface policy, interface policy group, interface profile, and switch profile. Then logical construct, we discussed tenant, VRF, BD, application profile, and EPG. So if you do all these two things now, still you are not able to communicate. For communication, we have to bind physical and logical construct. And how we can do that thing? Under EPG, we are getting a option domain, associated domain, whatever domain you have, physical or virtual. Then define endpoints in EPG. So under EPG, you will get an option static port, where you can define, okay, the endpoint connected on leaf 101 on the interface 1/12. It belongs to VLAN 100, deploy immediate, and it is access port like that way. After that, they can communicate. Getting my point? Any confusion?
Good for me.
Okay.
Screenshot done, guys?
Yeah, it's done from my side.
Now, so this is what the theory part. Okay. Now let me show you one, whatever I have discussed. Let's do one lab activity, okay, which you have done already in the last course, and based on that, I will discuss the packet forwarding. Okay. So I'm taking the same example. I have two endpoints, one connected on leaf 1, one connected on leaf 2 on the interface 1/12. Okay. So fabric access policy. So first step is VLAN pool. Right click, create a VLAN pool. Any name you can give. Let's say I'm putting test VLAN pool. Allocation mode, static or dynamic? Static, because my endpoint physically connected there. 500 to let's say 600. allocation static, submit. Then, according to our configuration, we have to create the physical domain. So I'm putting, let's say, tests, physical domain. A test VLAN pool, creating the domain, associating the VLAN pool. Then you can create the AEP now, point number 3, under the policy global attachable access entity profile. And test AAEP, associate the domain, update, next, finish. Okay. Point number 4, we have to create the policies. So let me create 1 gig policy. Then we have to create a CDP policy. It's not mandatory. Okay. Then policies are created. Then we have to create the interface policy group. So under the interfaces, policy group, leaf interface policy group. So I'm giving a name, IPG1. Associate the policies which you have to create and associate your AEP. Then interface profile. My endpoint connected on port number 1/12. Associate the policy group. Then create a switch profile. It is just a name. Under the blocks, you have to select your leaf devices. Don't select the policy group because the policy group already associated into my interface profile. Associate that one, finish. Any confusion, anyone?
Looks good.
Okay.
I'm
So,
okay.
let's access our endpoint also side by side. Show CDP neighbor. You can see here, I'm getting the leaf neighborship. That means whatever policies I have pushed to my leaf interface, that works perfectly fine. Show CDP neighbor. Okay, great. Now, If I try to ping my endpoint, it will not ping. Reason, I just configure only the physical construct, not the logical one, right? So now let's configure the logical one. So under the tenant, add tenant. So let's say I'm putting production one tenant. Under the networking, VRF, create a VRF. Here you are getting the option create a bridge domain. Otherwise, you can right click on the BD and you can create separately. BD1, submit. In the BD1, you can create the subnets. Let's say 20.0.0.254/8 private to VRF. Private to VRF meaning is what? Like, okay, we can communicate within the VRF only. And which VRF? Where that BD associated. This BD associated in VRF1. Then application profile, create an application profile. Inside this application profile, you will get an option application EPG. App EPG. EPG associated with the BD. Okay. And now we have the physical construct, we have the logical construct. We have to combine those two configurations. So under the EPG, you have the option domain. Right click on this, associate your physical domain. Then you have to define the endpoint under this app EPG. So right click on this static port. Endpoint connected on leaf 101. Interface 1/12. VLAN, let's say 500. Deploy immediate. Access untagged. Okay. Submit. Another endpoint connected on leaf 102. If you put here different VLAN also, it will communicate, no issues. But that VLAN must belongs to the same VLAN pool. Okay. Under this operational, thing 20.0.2. Okay. It's pinging. One endpoint learn, it learn another endpoint also soon. Another endpoint is also coming. Now, if I access my 192.168.10.65, admin. I'm accessing my controller, and through the controller, I am going to my leaf 101 right now. Okay. If here I run the command show endpoint, So if you focus here, this portion indicating your LST. This portion indicating your GST. And to check all these, we have this command. Any confusion, guys?
Looks good.
Everyone?
It's okay. It's clear.
Okay. So guys, my speed is okay. You are able to understand, or I have to slow down myself?
Good for me.
I think the speed is okay.
Okay. Cool. So now we have to discuss ACI advanced packet forwarding. Okay. So now we are going to start the DCACIA. Okay. Need any break, guys? Tea, coffee break?
Yeah, we need one.
Okay. So cool. Then do one thing. We'll meet after 15 minutes then. Okay.
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 Cool.
All right.
Guys, I'm back. I hope my screen is visible.
Yes, I can see it.
So first thing is what? Packet forwarding between the leaf switches. Endpoint are stored into the endpoint table on the leaf. Local endpoints are the main source of the endpoint information for the entire ACI fabric. The endpoint information contain basically what? What is the MAC address? What is the IP address? In which VLAN it belongs, and it is local or it is remote. Okay. Each leaf is responsible for reporting its local endpoint information to the Council of Oracle Protocol database, which is located on each spine. So, COOP database or PST will be generated only on the spine switches, and if we have the multiple spine switches, then every spine switch have the same database. Each endpoint into the endpoint table has the location and the EPG or the MAC address, IP addresses. This information is used to route or switch the packet and used to apply a contract. Okay. ACI learn the endpoint for both MAC and IP address from the data plane, which is different from other normal switches. Okay. Let's see how. Now, so in this picture, if you see, I have 3 endpoints which is connected on the respective leaf switches. They have their own database, which is LST database. Between the spine and leaf, there is a COOP protocol. That COOP protocol works between the leaf and spine, and they give their LST database to the spine. Spine create a COOP table, which is basically COOP database or the PST database. Okay. Next. Just give me a second. Hello, yeah. Hello, ऊपर देख. Six eight four 571. This leaf is sending any data to this leaf. So endpoint A send a packet. Okay. Ingress leaf learn the MAC and the IP address A via the data plane of the packet. In that there is a information what is the source and what is the destination. If right now it is checking where into the LST. Now I don't have that information into the LST. Then what will happen? Ingress leaf report endpoint A information to one of the spine COOP. Ingress leaf send the packet to the egress leaf, right? So here the next option, it will check BD options. By default into the BD hardware proxy. Hardware proxy is enabled. Second option is flood. Okay, we will discuss that thing. What is the difference between them? But by default, hardware proxy is enabled. So when there is no information into the LST, due to the BD hardware proxy, the traffic is forwarded to the spine. Spine share a new COOP data to other spine. So that means they have the same database, same COOP database. They will check the database. Based on the database, they will egress leaf learn the source MAC and the IP address from the inner packet of the VLAN. So it will forward it here, reach to the destination, and it will give reply. Once this reply came, then this VXLAN tunnel will formed automatically. For example, in our case, check this one. Show endpoint. here we have both the endpoints are learned here. Here also it should learn. It's not learning that. It's no issue. Show interface tunnel 29. Okay. So that tunnel 29, if you see, tunnel is up. Transport protocol is VRF overlay, the internal communication. The tunnel is what? IVXLAN. See this thing. Tunnel source and destination. These are the TAP IP of leaf 101 and 102. Getting my point? Focus here 64, 66. If I go to my fabric, inventory, fabric membership, you can see 66 belongs to leaf 102, 64 belongs to leaf 101. Getting my point? Yes, guys? Any confusion? Yeah, sure. Let me just tell you. Currently, we have done this thing. So here we have 20.0.1, 20.0.0.2. Fine. They are connected on 1/12. They belongs to app EPG. Right? When you communicate once, then automatically what is happening? One VXLAN tunnel will form. Automatically. That is what? IVXLAN tunnel. Every tunnel is having the source IP and destination IP address. Here, all these devices having the TAP IP. (10.0.168.64), 10.0.168.66. So this IP address as a tunnel source, this IP address is a tunnel destination here. And now when this endpoint is sending any data, right? So the data is going like this way, going to the tunnel and then going to the destination. Getting my point? So the next discussion is based on this particular topology. So in this topology, if you see, we have leaf 101, 102, 103. There they are creating a VRF1, PD1, PD2. There are certain EPGs and L3 out connection. Okay, and we have two spine switches. Okay. Now let's see the case scenario. So there will be the 4 case scenarios now. Case 1. Source leaf knows the destination and destination is on the same leaf. For example, let's say 20.0.0.1, 20.0.0.2, 20.0.0.3. On this PC, if I'm sending a request, ping 20.0.0.2. Okay, so what will happen? On that switch, on the LST database, there is a information, let's say 1/1, 1/2. Okay, so what will happen? If the source and the destination present on the same switch, then there will be the local switching, local Ethernet networking. Okay, it will not forward the traffic into the ACI. Getting my point? ACI works here in this network, but it is connected on the same switch, so local forwarding will happen. It will just check the database into the LST. It will get that thing, okay, 20.0.2 locally connected with me. So it will forward directly. Getting my point? Clear this thing, guys?
Yeah, that's clear.
Yeah, for me as well.
So if the destination MAC is known on the ingress leaf on the same switch, and it is on the same leaf, the packet forwarded to the local port like the traditional layer 2 or layer 3 forwarding. Clear? So endpoint 1, endpoint 2, it will forward locally. Okay. Now, destination MAC known reside on the local switch. So both the endpoint learn locally on the LST database, so it can forward. No issues. Now, source leaf knows the destination on the different leaf now, but source leaf knows that thing. How it knows? Let's take that example. So when the local station database will create, it is having this information. Once there is a communication, once this communication is established, this IVX LAN tunnel will form. Let's say 29. So here there will be information about the GST. Clear? So that means I have this information on my leaf. Okay. Now, if I'm writing now ping 20.0.0.2, what will happen? So the request will forward it here. Now the request will check into the endpoint table. It will check the LST database, GST database. It get that information. Okay, 20.2 I am receiving via the tunnel 28. Okay, so this switch will not forward that request to the spine. It will forward that request to this tunnel. Getting my point? Clear this thing? Endpoint
Yes, clear.
learning. Source leaf. Nose. Destination. Okay. Guys, everyone, do one thing. Start your discovery number 1. Just click on begin lab. Okay, it take time, almost 20 minutes. So in the meanwhile, I will discuss the theoretical portion also. Everyone initialize the discovery 1. Start lab 1. Discovery 1 started, guys.
Yes, mine is loading.
Okay.
Beg your pardon?
How much time it is showing?
20 minutes. Estimated reset time is 20 minutes.
Okay, cool.
Initializing devices.
source leaf knows the destination, destination on the different leaf. So what will happen? Destination knows reside on the remote leaf. So firstly, the endpoint will hit to the leaf, local leaf. It will check the endpoint table. The MAC address is present on the leaf 2. It will forward the traffic. Okay. Now, internally, this thing happen. Internally. Okay. 3. Endpoint 1 is sending the traffic to the leaf 1. Okay. So there will be normal Ethernet packet where we have the source MAC, destination MAC, source IP, destination IP address. Okay. This leaf is behaving kind of VTAP, VXLAN tunnel endpoint. So what it will do, it will encapsulate your layer 2 header into the VXLAN header. Okay. It add the VXLAN header. Once it will add the VXLAN header, then it get this particular information. This is your actual layer 2 header, and this is the VXLAN header. In that VXLAN, what is the source IP address and destination IP address? This is the tap IP address of this and this. Okay. So this information is forwarded to the spine. Spine is checking what? Anika step is used for the proxy, not used in this scenario. Okay. Why? Because in this case, it knows the destination information. So it forwarded here. This packet came here. It will de-encapsulate this packet. The normal Ethernet header or packet will be forwarded to the endpoint. It will give reply same way. Traffic flow between the two endpoints. Now, MAC and IP address of the both endpoints are known, right? The endpoint 1 known as a local endpoint to the leaf.
I'm gonna brand new iPhone, okay?
Sorry. Hello. Any question?
No, good.
Okay. So here basically whatever I discussed in this last slide, here, this is the explanation of this. That's it. How this packet is moving. Okay. Now, as I mentioned, like by default, the hardware proxy is enabled. So if you go to any BD policy journal, see this option, flood hardware proxy. Hardware proxy is by default enabled. Okay. Let's see in our scenario. We have created a BD1, right? Under networking, BD1, BD. See? Now, what do you mean by hardware proxy enabled? When the traffic hit to the leaf, if that leaf is not having the destination information, then it will forward to the spine. And spine have all the active endpoint information. So spine will forward that to the destination leaf. Getting my point? Any question into the hardware proxy? What is the meaning of flood? We will discuss that thing.
I think that is understood.
Okay. Now, next option is source leaf does not know the destination. Okay. So first option is spine proxy. So what will happen there? If the endpoint address is not known to the ingress leaf, then there are two options. First option is spine proxy, which is a hardware proxy. happens mainly in three scenarios. What are those scenarios? First, packet is a unicast layer 3 packet and the destination IP unknown to the ingress leaf belongs to one of the BD subnet. Okay. The packet is a layer 2 switch packet and the BD layer 2 unknown unicast mode is set to the hardware proxy. The packet is a ARP request, broadcast request. The BD ARP flooding is disabled. Then these are the three case scenarios when the packet is forwarded to the spine. Now, if I draw this, let's suppose it belongs to app EPG, web EPG, and both belongs to, let's say, BD1. So here we have the BD1. Under this BD, I have, let's say, 20.0.0.254, 30.0.0.254, 20.0.1, 20.0.2, and 30.0.0.1. Okay. Now, so these are the conditions. Either I'm going to communicate under the same subnet. Okay. Then it will forward to the spine. Second case scenario, I'm going to communicate under the different IP subnet, but that IP subnet is associated or put inside my BD subnet. Getting my point? These two scenarios are clear?
Yes.
Okay. Third scenario is if I'm sending a ARP. Okay. I want to resolve a ARP, and ARP is a kind of broadcast. Okay. So if there is a ARP broadcast, that also forwarded to the spine. Getting my point? Based on that, I hope you have already discussed that thing in your last course. Let me just this one. Now, layer 2 forwarding. Let's say I have 20.1 and 20.2. Those are present on the two different leaves. So how the internal things are happening? See, packet coming to the leaf. Let's say packet coming to the leaf 101. But it will check. It is a layer 2 or layer 3 packet. Let's say layer 2. How I will get to know like layer 2? Because I'm going to communicate under the same IP subnet. Getting my point? Clear, guys?
Yeah.
Then once it reach here, it check layer 2 or layer 3. Currently, I'm focusing on layer 2 only. So it check, okay, it's a layer 2 packet. Okay. Then does leaf knows the destination MAC? Currently, where I am? I'm on the leaf 101. What I'm checking? I'm checking my LST database right now. Clear on this particular point? So either I have the database or I don't have the database. Let's suppose I have the database. So again, there will be a condition. Is the destination MAC on the local leaf? If yes, then local forwarding will happen. If no, in that case, that MAC address, destination MAC address, I am learning through any kind of tunnel. So it will forward to the egress leaf via the tunnel. Getting my point? This particular section is clear or not? This one.
Yeah.
Yes, guys? Okay. Now let's focus here in this way. Let's suppose my leaf don't know the MAC address. Then what is the BD config? It check hardware proxy or the flood. By default, hardware proxy is there. So it will forward that traffic to the spine. Now spine check their database, COOP database. If information is present there, then forward to the egress leaf. Otherwise, packet will be dropped. Getting my point?
Okay.
Now, hardware proxy by default enabled. But what will happen if you flood the traffic? If you enable that flooding? If you enable the flooding now, then the traffic will be flooded to within the bridge domain. It will not forward it to the spine. It will be flooded within the bridge domain. Getting my point?
Okay.
Guys, any question in this particular flow chart? At the end, I will share this my PPT to you. Okay, so that you will get everything. Recap. So these are the scenarios like which I just discussed there. Okay. Again, with all these screenshots are now they are in the books. I just taken from the books only. Okay. So destination MAC unknown, bridge domain is in lay to unknown unicast flood mode. Okay. Flood mode meaning is what? It will flood within the all within the BD in all EPGs. Okay. Now, what is the flood mode? Hardware proxy is simply like if you don't know the information, then forward to the spine. Flood mode is little bit complex. Like you should know that thing when I have to enable the flood mode. Now, firstly, let's understand that scenarios, and then I will read out all the theoretical portion. Now, I'm taking the 3 leaves. Let's say these two belongs to app EPG. This belongs to app EPG. This belongs to web EPG. This belongs to web EPG. This belongs to DB EPG. Whatever subnet is there, no issues. Okay. Now, app belongs to app EPG belongs to, let's say, BD1. Web EPG also belongs to BD1. And DB EPG belongs to BD2. This DB EPG. Okay. Now, firstly, if it is hardware proxy, BD option, then it will go to the spine and spine will do that. But in this case, there is a thing. If there is, let's say, whatever PST database is there, if there is no information now, so packet will be dropped here. And what can be that condition? If you have the Ethernet switch, there is a option MAC aging timer. Yes, guys, what is the MAC aging timer into the normal switches? Anyone?
The time it takes for the LAN's MAC address to stay in the table before it kind of is expired. If, for example, there's no communication
Correct.
from that address.
Right. So what is the timer? How much time?
I don't have the figure of it.
5 minutes. Okay. 5 minutes in the normal switches. But in the ACI endpoint retention policy, local endpoint 900 seconds and remote endpoint 300 seconds. Remember this point. Okay. Local endpoint, let's say you are on this switch, so it will learn these local endpoint information till 900 seconds and remote endpoint 300 seconds. Now, let's suppose currently this is active. So my leaf will learn the endpoint information, no issues. But let's suppose it goes into the sleep condition automatically. You are not working, or let's say you are on the lunch break, and on this particular endpoint, there is no traffic and it goes into the sleep condition. So after the 900 second, leaf 101 remove that entry, correct?
Correct.
If that information, yes, after 900 seconds, if that entry removed from the leaf 101, it will also remove from the spine also. Because spine get that information from the leaf 101, na?
Yes.
So if any other endpoint is sending traffic to that particular node, my spine is not having that information, the traffic will be dropped. Right? To avoid such scenario, what we can do, instead of hardware proxy, we can use the flood option. Okay, just to drop that scenario, like, okay, maybe due to the sleep condition, right, my spine is not having that database. Okay. Clear? Yes, guys. Any confusion? This is one of the case scenarios. So in this option, the packet is flooded within the bridge domain. Flooded within the bridge domain meaning is what? Let's suppose, let me take IP address 10.0.0.1, 2, 3, 4, 5, 6. So I'm on this app EPG thing to, let's say, 10.0.0.5. Okay, to this guy, and I choose the option flood. So what will happen? The traffic hit to the leaf. Leaf firstly check LST. I don't have this information about 10.5. So then it will check the option BD. Under the BD, again there are two options, hardware proxy and flood. This time I have selected flood option. Flood meaning is flood within the BD. So this app EPG belongs to where? Under the BD1. Okay. And BD1 is also associated with the web EPG. So the traffic is going here, here, and here. Getting my point?
Yeah.
It flood within the EPG. Sorry, within the BD. This packet is not for this guy. It will drop. Not for this. It will drop and it will give reply. Clear my point?
Yes.
Second case scenarios. Okay. In the ACI, forwarding tag tree are built to load balance multiple destination traffic and to avoid any loop within the infra VRF. Okay. By default, within the spine and leaf, there is a infra VRF, which is the overlay one. One of the spine switch. One of the spine switch is chosen as a F tag tree route. Okay, if you have the multiple spine switches, one of the spine switch will be treated as a F tag tree route. Route build the branches to every leaf switch directly connected to that particular spine switch. Then it is showing in the example, like whatever example we have previously. Spread to another to reach the other spine switch. So the path of the all node built with a loop free path. So meaning is what? If you see this particular example, endpoint 1 going to communicate to endpoint 2. Okay, they belonging to the same EPG. Okay, let's say, and you selected the flood option. So it will flood within the BD, but when it is flooding that thing, one of the spine switch will behave as a route. Okay, because it is flooding. Maybe it reached to the leaf 3. Leaf 3 will forward to the spine, right? Because it is a flooded traffic. So just to avoid that particular situation, one of the spine will be elected as a route. So only that route will be the authorized one. Getting my point? So in this case, if this spine is sending the traffic, then it will be simply block. That is not authorized. Getting my point?
Yes.
The same thing I have written here. Now, layer 3 forwarding. So previous example I have given with same subnet. Now, different IP subnet. See what will happen. Endpoint is sending traffic to the leaf. Okay. Let's say this is having 20.0.0.0.1 IP address, and I sent a request to 40.0.0.1. So traffic is coming to the leaf. Now leaf check L3 packet coming to the leaf. How it will get to know it's a layer 3 packet? Because I'm going to communicate into the different IP subnet right now. Okay. Sorry. In the different IP subnet. So what it will do? Does leaf knows the destination IP as a endpoint? Now what it is checking? It is checking the endpoint table. Now, does leaf knows the destination IP? If yes, if the leaf knows that thing, so again there will be two conditions. Is the destination on the local leaf? Yes, then forward to the local port. If no, then forward to the egress leaf via VX LAN tunnel. This particular section is clear or not?
Clear.
Now,
Yeah.
let's suppose my leaf don't know the destination. So again, what will be the condition? Does leaf have the BD subnet for the destination IP address? So whatever BD you have created, in that, have you created the 40.0.254 subnet or any IP address of that particular subnet? If yes, then it forward to the spine. Does spine knows the IP address? If yes, then forward to the leaf. If spine don't have that information, you put that subnet under the BD, but that is not having the information on the spine. In that case, packet will be dropped and ARP gleaning for the destination. What is this ARP gleaning? We will discuss that point. If no, if I haven't defined that thing under the BD, then what will happen? Maybe that 40 network I am getting via the routing, via the L3 out. So that does leaf have the external route for the destination? If yes, that means it will forward as per the routing table. If no, the packet will be dropped. Getting my point? Any point you want to ask here?
Looks okay for me.
Now, what is this ARP gleaning for the destination IP address? Now, understand this particular one. It is telling that thing. (20.0.0.1), 30.0.0.1. Under my BD, I have defined 20.0.0.254, 30.0.0.254. Okay. On this PC, I'm just writing a command, let's say ping 30.0.0.25, let's say. Okay. So see what will happen now. Leaf 101 is not having that information. So what will happen? Does leaf have destination subnet for IP? Yes, I have the 30 IP at the subnet. Okay. So then this traffic will be forwarded to the spine. Okay. But in the spine, I have only 30.0.1 information. I don't have the 30.0.0.25 information. I don't have that one. So what will happen? If it is not learned by the spine, it will drop. That request is drop here. But you have defined the subnet. So what it will do, it will send a broadcast. It thinks that thing, maybe that is under the sleep condition. So what it will do, it will send a broadcast packet to same BD. Just to check that thing, okay, this 30.0.0.25 is present or not. Maybe that is into the sleep condition. It gets that packet, it will reply getting by the spine. Then once it get, automatically this entry will be generated and the next packet will be communicated. Getting my point? This is the meaning of ARP gleaning. If the spine is not having that information, so packet will be dropped and it sent one packet to search that endpoint. Clear, guys?
Clear.
Any question, guys? Anything?
I'm good.
Okay. So let's see what they are doing into the discovery one. Let me just open that one first. In the discovery one, they are searching for, like, they are learning the endpoint and local, remote and local endpoint learning. So in this particular lab, most of the configuration is pre-configured. Okay. So you have to just verify that thing. Okay. You will get a complete procedure document here. You have to follow that procedure document. Okay. This will be your topology. You have one spine, two leaf. You have one catalyst switch connected, one ESXi server connected, where they are doing the VMM integration. Okay. Anyone started the lab? If lab is started completely, just share your screen. I will explain that thing there. Anyone whose lab is started?
Mine is ready to begin, but not yet started. But now I can.
Okay. Cool. So let's say, who is sharing the screen? Samuel? Yeah. Okay. Okay. So no, I'm able to see one screen right now, but I'm not sure who is sharing right now. Okay. So yes, correct. So if you go a little bit up, somewhere you will get, like, on the top, you are getting that thing, introduction, job, add, procedure document. Okay. So all the devices, username and IP address is there. Procedure document is there. You have to follow the procedure document. Getting my point? Click on the procedure one. Click on the procedure. Okay. Yeah, I'm able to see. This is your procedure document. Okay. Okay. One more thing. Somewhere, let's say, in the procedure document, if you are getting that thing, IP address is, let's say, 192.168 1x.10. X meaning is your port number. Getting my point? Okay. So just a second.
Say
Let
that
me
again,
share.
please.
Just a second. Let's say in this procedure document, okay, maybe somewhere in this procedure document, you will get like this way. In the procedure, if you are getting any IP address like this way, 192.168.1x5.10, let's suppose. Okay. So this X meaning is the port number. Now, how you will get the port number? I have shared that information. For example, Lordwin is having port 1, Samuel is having port 2, Nicholas is having port 3. Getting my point?
Yes.
So instead of X, you have to type your port number. So for example, like, it will become, for Samuel, it will become 192.168.125.10. Getting my point? X meaning is your port number. Okay.
Okay.
Now, these are the device username and passwords. Okay. Now, so what they are doing, logging there. One spine, two leaf devices are there. So in this lab, actually some configuration is pre-configured. Okay. You have to just verify the things in this lab. So whatever we have discussed in the morning, na, VLAN pool associated into the domain, domain associated into the AEP, AEP associated into the policy group, then profile associated here, and then it associated with the switch profile. So they are doing the similar kind of stuff. After that, they are doing the VMM integration. And after this, they are checking ping, all those things. Show endpoint. Okay. Show VLAN extended. Okay. On the VLAN part, we have to discuss. Okay. In the ACI, there are some different type of VLANs are there. Okay. We will discuss that thing. This is the COOP database. How you can check show COOP internal info. Okay. Then they are doing one activity, VPC, virtual port channel. This VPC lab you have done into the last week. Have you done that thing last week, VPC? Yes, guys. Yes or no? VPC.
No, we didn't do VPC.
Sorry?
We just talked about it, we didn't do it.
Your voice is not coming properly.
We talked about it, not.
Okay, lab is not done. You just discuss it, right?
Yes.
Okay.
Lab was not done.
Okay. Let me discuss that thing first. Okay, you know that thing, what is VPC? Or should I explain that thing also? Yes,
You
guys?
can explain.
Okay, cool. No issues. VPC. Virtual port channel. Now let's see that thing, how this VPC come into the picture. In our production environment, previously we have this kind of topologies. Switch 1 connected with another switch, connected with another switch. This kind of topology is known as daisy chain. In this, what is the issue? If this backbone cable goes down, so network will be separated, right? Then we get one solution, put the multiple link between them. This kind of topology is known as what? Redundant topology. Okay. So in this topology, single link failure issue resolved. But STP work in redundant topology. And due to STP, we are not able to utilize full bandwidth. Correct? Because STP make one link active and another links into the blocking state. Correct? Then we get one more solution. port channel. Now here we get redundancy. Bandwidth increase. STP remove. But port channel provide link redundancy, not device redundancy. Now, what is the meaning of this? If switch down, port channel will be down. Clear, guys, till now?
Good.
Any question? Take the screenshot. Screenshot done.
Yeah, it's done.
Okay. Now, next solution is VPC. VPC provide link redundancy and device redundancy. Okay. Now, VPC is supported only in Nexus switches. It support in 9K, 7K, 6K, 5K, and in some model of 3K also. VPC is layer 2 technology. So now what is happening into the VPC? Say 9K1, 9K2. VPC terminology. First terminology is VPC domain. What is that VPC domain? VPC domain is that logical entity which makes two upstream switches as a one logical switch. Okay, So here you will define a VPC domain, let's say 5, domain ID 5. Okay. Point number 2. Okay. You can configure only one VPC domain on one switch, and in one VPC domain, maximum 2 switches can participate. Then VPC peer. VPC peers are those switches where you will configure the VPC. Where you will configure the VPC. Point number 3. VPC peer link. VPC peer link is a layer 2 port channel link. Layer 2 port channel link. Okay. Link must be 10 gig, and this particular link used to synchronize the control plane of the VPC. Control plane of the VPC. Okay. Inside the peer link, there is a protocol CFSOE, Cisco Fabric Service over Ethernet, which is used to synchronize the control plane. Point number 4. VPC keep alive link. VPC keep alive link is a layer 3 link actually. Now what this link is doing, it is just keep checking about the peers, right? Your peers is alive or not. So it is carrying basically the heartbeat messages. DSD. DSD is what? Downstream device. So this DSD can be a switch, can be a firewall, can be a load balancer, and can be a server also. No issues. Point number 6. Member ports. Ports on the VPC peers, which is going to be connected on same device, same DSD. Member port. Point number 7. Orphan port and orphan device. Let's suppose if we have here any switch like this way. So a switch which is connected with only one VPC peer, that is known as orphan device, and that connected port, orphan port. Yes, guys. Any question, anything which I have to revise?
Looks good for me.
Take the screenshot. Screenshot done?
Yes.
Can I clear it? This is the normal Nexus explanation which I have given. Now let's see how it is into the ACI. So VPC in NXOS. So if you want to configure, what is the mandatory thing for VPC? First, domain ID is mandatory. VPC peer link is mandatory, and VPC keep alive is mandatory. These are the mandatory things. Okay. In the ACI, VPC work here. So we have to define the domain ID. Okay. No keep alive. Required. No peer link required. Why? Because see, all the spinal leaf devices, they have the tap IP address. And the tap IP address belongs to the same subnet. So internally they have the communication. That's why no keep alive required. No peer link required. Why? Because between the spinal leaf, we have the high speed fabric connectivity, minimum 40 gig. That's why internally they will form automatically the layer 2 connectivity. Getting my point?
Got it. That's clear.
Cool. Screenshot done. Yes, guys, screenshot done. Okay. So VPC configuration in ACI. So what do you have to do? Let me check if the switches are working there, then .6. Fine. I'm going to make a port channel here, VPC port channel. Okay. Right. So point number 1, with respect to the configuration, you have to create a VLAN pool. Okay. Point number 2, domain. And here domain will be what? Physical domain. Associate VLAN pool. Point number 3, AAEP associate physical domain. Point number 4, interface policy. So I will create the link level policy, let's say CDP policy, and the port channel policy. Okay, LACP policy basically. Then interface policy group. Here you will create a VPC interface policy group. You will associate interface policy and AAEP 6. Interface profile, define interface, and associate policy group. Point number 7, you will do what? VPC configuration. And point number 8, switch profile. These will be the steps. Just take the screenshot, then I will show you this lab.
Screenshot is done.
Screenshot done.
Yeah.
Okay. So switch 2 is connected on port number 15, 1/15. Getting my point? Switch 2 connected on 1/15. Okay.
Yeah.
And they are connected with a fast Ethernet. So now, some of the configuration is already there on my Epic from the last lab. Okay. So I will not going to configure like VLAN pool domain again and again, right? I will utilize them only. So point number 1, we have to create a VLAN pool. That VLAN pool is already there, correct?
Yes.
Point number 2, we have to create a domain. The domain is already there, and in this domain, I have already associated my VLAN pool, correct?
Yeah.
Then AAP is already associated here, no issues. Okay. I need one more policy now, which is 100 MB. Let's say 100 MB policy. Speed should be 100 MB. Okay. I need one more policy, port channel policy. Policy 1. Under this PC policy 1, I'm selecting LACP. Next switches, they just support the LACP protocol. They are not supporting PHEP. Then we have to create a interface policy group. under the policy group, you have a option VPC interface policy group. Right click on this, create a VPC interface policy group. VPC policy group. Under this, associate your policies. Port channel policy and your AAEP. Submit. After this, we have to create an interface profile. Our interface, which is connected with switch, that is port number 15, 1/15, and associate with the policy group. Then interface profile is done. Then the VPC configuration. Under this quick start on the top, you have one option, configure an interface port channel and VPC. Click on here. Click on this green plus option. Switches. I have 101 and 102 where I want to configure the VPC. It automatically creates a switch profile. I'm just renaming it. VPC switch profile. It will create automatically VPC switch profile, and these two leaves are there. This is the VPC configuration here. Click on the plus sign. VPC domain ID, let's say 5. Switch 1 is, let's say, leaf 101. Switch 2 is the leaf 102. Save. Submit. Done. After that, you can verify that thing. VPC switch profile is there. That switch profile is having the leaf, but that is not having the interface profile. From here, you just select that interface profile. Then VPC configuration. Here, show interface, show port channel, ether channel. Show ether channel summary. Okay. Few port channels are configured. Just no interface port channel. Three, 5, and 10. Default interface. So interface range FA1/0/1-2. Switch port. On the downstream device, I'm just going to configure the port channel. That's it. Channel group. 3. Mode. Passive. No shut. Exit. Interface port channel. 3. Switch port. Switch port trunk encapsulation .1q and switch port or trunk no shut. Then show ether channel summary. Okay, it is showing here my port channel is up. One port is down. Maybe it will coming up. Okay, or maybe there is a issue on physical cable. Okay, but our port channel is up. It is showing here. I can go to my leaf devices. Let's say 192.168.10.70, let's say. Okay, it's working. On the leaf, if I'm running a command, show VPC. Show VPC. You can see my port channel is up, peer agency formed okay, and downstream port channel is also working fine. This is what my VPC lab. Getting my point?
Yeah.
Yes, guys. I will share one document regarding this. Okay, I have one screenshot of the entire lab. I will share with you. Okay, no issues. I hope at your end it is 1 p.m. right now, correct?
Yeah, that's correct.
Okay. So you will continue the lab or you will go for the lunch break first?
You can have a lunch break, then we do the lab.
Cool. So we'll meet at 2. Okay. So
Okay.
everyone will back at 2. Okay.
Okay.
And start this lab.
Maybe one more thing. I don't know how to do this. I don't know if you can hear me. I have an urgent meeting that's been called up to for 2 p.m. I need to attend. I don't know how we manage.
Cool. No issues. But at what time you will be back?
Supposed to take about 40 minutes.
No issues. Okay. Once, like after this, I have to discuss 2 more lab. Okay. Firstly, they are going to discuss. They will do the lab. So almost it take 40 minutes. So if you are coming in that same time, no issues. Otherwise, I will explain you separately. No issues.
Okay.
Okay.
All right. Thank you.
Okay. Cool. We'll meet at 2.
Okay.
This entry will be reached to spine by the COOP database. AA is present on leaf 101, correct? Any confusion? Now let's suppose you have changed your seat from here to here. Okay. I have told you that thing, local endpoint store in LST till 900 seconds, correct? This actual PC moved here. Okay. Now, what is happening? This still have that information into the database, right? It is still connected with me. And this is giving this information via the COOP protocol. Okay. When it is connected here, then it will update the LST here, and this will give this information. Okay, AAA is connected with 103. Till now, all good? Now, this entry will stay here till 900 seconds. Now, we need some faster mechanism so that the entire, right now I am taking only 3 devices, 3 leaf switches, but suppose in the production environment I have 20 switches. In that case, there will be a big issue. So right now what is happening, this device moves here. Okay. Now let's suppose this particular VM, if it try to communicate, let's say ping and point 1, which we are doing right now. So the traffic is going here, it check that thing. Okay, I have 2 information. Okay, so it receive the same information from the 2 leaf, which is not correct. So in that case, either this entry is wrong or this entry is wrong. Okay, so it will check both endpoint. Now it identifies that thing. It is not present here. So whatever information is there in the LST, it will be represent as a B. B meaning is bounce entry. Okay. So let's suppose if this endpoint is sending the traffic for AAA, it is going here. Here it is B. B meaning is what? It is bounce entry. If it reach here, it will be redirecting to here. Okay. Due to what? The bounce entry. Once it gets communicated, okay, I communicated via 3. So then only this information will be updated here into the GST. So currently what is happening in this one, this bounce entry is created the problem. So I check on both the leaf. Here it is showing also bounce, and here it is also showing the bounce. But whatever is the rest of the command now, let's say what they are doing. They are verifying the show interface tunnel. This tunnel number will be changed for everyone. Okay, because this tunnel will formed automatically. So if it is in the procedure, it is 2. Maybe when you are performing the lab, it can be 10, it can be 11, no issues. For example, here it is showing what? Tunnel 1. So I can check that thing. Show interface tunnel 1. So it is telling that thing what? VXLAN, what is source, what is destination. Okay, similar kind of output we are getting. After that, ACI diag FNV read, it will show you all the registered leaf. ACI diag FNV read. Okay, so you can check that IP address from here. What is the next command? Ping app. Okay. It will not ping. Okay, the reason is the same, the bounce entry. Once that is resolved, then everything will be working fine. Okay, the issue is only that bounce entry. Rest of all the commands are working, just this communication is not happening right now. Getting my point? Or we can test one more thing. If I check the contract, This issue is only with the bounce entry. I have allow ICMP also, still it is not working. That is what. Bounce entry we will discuss tomorrow. Bounce entry we will discuss tomorrow. We have the complete chapter of bounce entry, and we have one lab on that also. You can see that thing. The second lab is related to the bounce entry. So in the morning we will do that thing, bounce entry, not an issue. Okay. So guys, tell me one thing. Do you have the still access of this lab, Koenig lab? Yes, guys.
I beg your pardon.
I tried accessing it earlier and it was opening.
Okay, opening. Guys, do one thing. Today you will test VMM integration. Okay, whenever you get the time, just try to do this particular lab activity from the beginning. Okay, VMM integration, because whatever lab we are accessing from the Cisco now, this VMM integration is pre-configured, most of the labs. Okay, so make sure you are good into the VMM integration.
Okay.
Cool. Okay, guys, one thing, someone have pasted one link on the chat, customer support. Are you getting that link? Yes, Nicholas, Samuel.
Yes.
Just a second. I just pasting that link once again on the chat box. Getting now?
Yes.
Okay.
Yeah.
Just click on that, and you have to just fill that feedback like how's your today's session. That's it. Okay. Tomorrow we will start from the bounce entry. Then there will be one advanced lab. Okay. And tomorrow we will talk on the L3 out also. Have you done the L3 out lab, guys? Last week? L3 out?
Yes.
Which protocol you use? OSPF or BGP?
I did OSPF, I think, but OSPF.
Link is invalid. It's working. Samuel, for you also it is invalid?
Yeah, invalid URL.
How it is opening on my end?
The link opened, but with an error.
When you
Monday.
click on submit,
No issues. I will update that thing. Okay, there is some issue with the link. Okay. Cool, guys. So tomorrow we will meet at the same time. Okay. According to your time, 9 a.m. Okay. And tomorrow, guys, we have to do lots of labs, and we will do a recap of your last L3 out also. I will show you L3 out with OSPF, L3 out with BGP also. Yeah. Sorry? BGP? No issues. I will show you the OSPF. I will show you the BGP. If needed, I will show you the EIGRP also. That's no issues. And have you done the L2 out? L2 out? Like extend BD?
We didn't do that.
Okay, sure. So why I'm asking these things, guys? See, again, you have next 4 days with me. So I want like, okay, whatever you have done in the last class, okay, if you did, that will be great. If you miss any point there, then let me know. I will cover that part also. And I will show you the lab. If you are, due to any reason, if you are not able to do the lab last week, I will show you that lab. Okay?
Okay.
Cool. Then we'll meet tomorrow same time, guys.
okay.
Okay.
Bye-bye.
Thank you. Bye.